السلام عليكم. Welcome to Physics Online course with Ms. Charlene for the grade 10 students at the Career STEM School. Now we are solving some problems on specific and latent heat problems. First question: increasing the flame intensity under a pot of boiling water will increase. Increasing the flame intensity doesn't change the temperature of the boiling water and doesn't change specific heat or the heat capacity, as they are constant for the same materials, and thus water specific heat capacity of the constant value. So increasing the flame intensity will increase the rate of boiling but not the temperature. Question number 2. 2 liters of water at 20 degrees Celsius mixed with 3 liters of water at 90 degrees Celsius. Suppose no heat is lost outside the system. The final temperature of the mixture will be. By substituting in the relation of heat lost equals the quantity of heat lost equals the quantity of heat gained. So by here we have a water mixed with another water. So the specific heat capacity is a constant for the same liquid, but the temperature, the initial temperature of the first liquid was cold, and the final and the other temperatures, the initial temperature for the other liquids was hot. So the temperatures will be moved, the quantity of heat will be moved from the hot water to the cold one. So by substituting for the mass here, 2 liters times the specific heat capacity, which is equal to 1000, times temperature final minus temperature initial, and here 3 liters times specific heat capacity 1000 times the final temperatures, as it is decreased by the final temperature. Okay, by substituting in these relations and by solving this equations for finding the value of the final temperatures, we get that the final temperature equal to this value, which is logic value, which is between the cold water and the hot one. Question number 3. 2 liters of water at 20 degrees Celsius mixed with 4 liters of water at 70 degrees Celsius. No heat is lost outside the system, as the system is isolated. So the final temperature will be as the same as we undergo here. We will substitute for the same values and get the final temperature to be of 53.3 degrees Celsius. Note that it cannot be 20 degrees Celsius, as it is thus the initial temperature of the cold one, and it cannot be 70 degrees, as it is the initial temperature for the hot waters, and logically it would be some temperatures between 20 and 70 degrees Celsius. Okay. Question number 4. 6 times 10 bar 2 gram sample of water at 90 degrees Celsius is mixed with 4 times 10 bar 2 gram of water at 22 degrees Celsius. Supposing no heat lost to the surrounding, what is the final temperature? As the same, but here the methods are given in gram, and this not affected on the value of the final temperature. Is the same here if we converted the two masses into kilograms. By it can be cancelled with each other, so we can keep substituting with the mass in gram easily. Okay. Question number 5. The heat transferred from the hot cup of water to the cold one, because the heat transferred here, the hot one has a more heat energy. Of course not, as the heat energy is constant value. It has more latent heat. Of course, it is constant also, and the specific heat also are constants, but it has more specific heat energy. not as it is specific heat energy. It's a constant value for the hot water, but this value for the hot one is larger than that of the cold one. Okay, so the heat transferred is the quantity of heat equal mc delta T. Due to the variation, the mass is constant and the change in temperature is constant, but the value of the specific heat capacity which differentiates the hot and cold one. Question number 6. Two spheres of copper and aluminum are equal in mass. At room temperature, they are heated together in an oven. What would happen here? The thing in this questions, we have to suppose which one has a higher specific heat capacity, aluminum or copper. As the higher specific heat capacity, and the material that has a higher specific heat capacity can tolerate a larger amount of quantity of heat to raise its temperature by 1 degree Kelvin or 1 degree Celsius. Okay, so aluminum has a specific heat capacity larger than that of copper, so it takes a longer interval of times to reach to the same temperature. Okay, question number 7. The specific heat capacity of iron is approximately half that of aluminum. Okay, if two balls of equal masses, one made of iron and the other made of aluminum, both are 80 degrees Celsius, are dropped into a thermally isolated jar that contains an equal mass of water at 20 degrees Celsius. Thermal equilibrium is eventually reached. Which one of the following statements concerning the final temperature is true? Let's think of this question firstly. As here he mentions that thermal equilibrium is reached. As thermal equilibrium is reached, the temperatures must be the same for all objects that is found in the system. So the both poles must have the final temperature which equalized with the final temperature of water. Okay? Okay. And we said here in these relations, the difference between temperatures maybe differs, but the final temperature is the same. Okay, there is an inverse relation between the specific heat capacity and the difference in temperature. So the final temperature is the same, but the difference in temperatures varies with the specific heat capacity. As a material that has a higher specific heat capacity, the difference in temperature will be lower and vice versa. Okay, question number 8. Knowing that the specific heat of aluminum is about 2.35 times greater than that of the heat capacity of copper. Okay, if two equal spheres of aluminum and copper are supplied with equal amounts of heat energy, what would happen to the temperatures? Okay, here let's guess which one is correct. Is heat capacity of copper sphere greater than that of the heat capacity of aluminum sphere? Here he mentions that they supply the equal amount of heat energy, so the heat capacity must be the same. Temperature of copper equal to that of aluminum? Of course not, as there is an inverse relation between the difference in temperature and the specific heat capacity. It cannot be correct. And also, this one not correct, as the aluminum has a specific heat capacity larger than that of copper, so the temperature of aluminum must be lower than that of copper. So the temperature of copper spheres must be higher than that of aluminum. Okay, in this relation, aluminum has a larger specific heat capacity, so the temperature must be lower. Question number 9. What is the amount of heat that is required to raise the temperature of 500 grams of water from 25 degrees Celsius to 75 degrees Celsius? Knowing that the specific heat capacity of water is of 4020 joule per kilogram degree Kelvin. Substituting in the relations of the quantity of heat Q equal mc delta T, and by converting these units into kilogram, okay, and then we will get the value of the quantity of heat in kilojoule. Question number 10. Heat has the same unit as, of course, work. Both of them are measured in joules, but temperature in degree Kelvin and the heat capacity is in this value, joule per kilogram degree Kelvin. Question number 11. The same energy Q enters 5 different substances as heat. What would happen here if the temperature of 3 grams of substance W increases by 10 degree Kelvin and temperature of 4 grams increases by 5 and temperature of 6 grams increases by 15 and temperature of 8 grams increases by 6. Which substance has the greatest specific heat capacity? By substituting in the relation of specific heat capacity equal Q over mass times the change in temperature, and getting the value, there is an inverse relation between the specific heat capacity and the value of mass times temperature. Okay, so substance X, which has a lower value of the multiplications, that it will has a highest specific heat. Okay. Number 12. The energy released when 10 grams of steam is split on the hand. Okay. This energy by putting the hand in the pulse of steam rising up, it will causes a conversion, or some amount of heat will be converted, some amount of steam will be converted back into water. So there is an amount of heat that is released as a latent heat. Okay, so this quantity of heat equal mass times L, and by substituting in this relation, the mass equal to 10 gram, which equal to 0.01 kilogram, times the value here for the latent, the specific latent heat, and so we can get that this latent heat that changes at 100 degree of water at the same temperature. And another quantity of heat that is released and that is given when this condensed water drops into temperature from 100 degree to 33 degrees Celsius, assuming that the temperature of the skin is 33 degrees Celsius. So there is here a quantity of heat that will be released due to the variation between the temperature of hand and the temperature of steam. So we can get the value of the quantity of heat mc delta T, and substituting for difference in temperatures, 100 for steam and 33 for the skin, and getting this value. So the total amount of heat that is released will be the summation of the two values, okay, which equals to 25 kilojoule. Okay, number 15, the unit of measuring latent heat. Latent heat here is formula mass times specific latent heat, which measured in joule per kilogram, as L equal quantity of heat over the mass. Quantity of heat measured in joule and the mass measured in kilogram. Question number 14. Which one of the following statements describes the correct states on heating a piece of ice from negative 10 degrees Celsius to 0 degrees Celsius? Okay, there is an increase in the temperature, so As the temperature increases, the internal energy would be increases. But there is no latent heat of fusion or latent, it will not change in states. It's in the same states. Okay, for solid state, and the temperature increases, so the internal energy increases but not remains the same. Picture number 15. The opposite graph represents two objects of different materials are heated. Which statement absolutely correct? Okay, this relation between temperature and heat. The slope, which equal to quantity of heat, which equal to the difference in temperature over the quantity of heat. This is the value of the slope. So, as a specific heat equal to quantity of heat over the change in temperature, relation represents the heat capacity equal to Q over delta T. So the slope equals the inverse of 1 over the heat capacity. So object X and object Y. Object X has a larger slope than Y. So that has the object that has a less slope, which is Y, will have a greater heat capacity, as object Y has a lesser slope than X, so it will have a greater heat capacity than X. So by this answer, I changed it from X to Y. Okay, picture number 16. If we have, suppose that we have an ice cube that is heated at a constant rate in a beaker. This ice melts and later the water boils for a short while, which graph shows the temperature change with time. Temperature change with time, it firstly melts and then reaches, okay, for it to be melting, the temperature rises and then it will remain constant at 0 degrees Celsius, and then the temperature rises, then it boils at, and then it remains constant at 100 degrees Celsius. So this graph will represent this situation. Which graph perfectly describes the heat energy gained by a piece of ice at 0 degrees Celsius and it changes into water vapor at 100 degrees Celsius. It's the same, but it represents the heat gained by a piece of ice at 0 degrees. It begins from 0, remains constant, and then decreases, and finally remains constant at 100 degrees Celsius. The opposite figure shows the increase of the temperature of a certain material if part number 3 represents the liquid state. Which of the following statement is true? This is the liquid states, so there is 4 and 2 represents a latent heat. Okay, here specific heat number 3, so the correct one will be 4. 4 is the latent heat, which it converts from a solid into liquid state, and 4 from liquid into gaseous state. Thank you.